Hello everyone, welcome to notes number 6. Here we are going to be talking about ecology. So we're going to be talking about food webs and food chains, and then we're going to go into the water cycle and the nitrogen cycle. So the main source of energy for all life on Earth is the sun. The sun is what gives energy to the plants, and then we eat the plants, animals eat the plants, etc. Without the sun, plants would not be able to make their own food. Therefore, the ultimate source of energy is the sun. Now there are different types of consumers. Consumers are things that eat other things. Okay, so if you consume, say, a bag of Doritos, that means you eat them. So consumers are things that eat. So one type of consumer is a herbivore. Look at the word, herb. You might think of parsley and basil and lettuce. Those are all different types of herbs. So these are organisms that eat only plants. So cows, deers, insects, and some birds are considered herbivores. So if you were a vegetarian, you would be considered an herbivore. Now a carnivore is organisms that only eat meat. Again, look at the word, carne, like carne in Spanish is meat. So these are your lions, your tigers, and your wolves that eat only meat. Now most humans are considered omnivores. Omnivores are organisms that eat plants and meat. So as long as you're not a vegetarian, you might have for dinner a steak with some salad. You're eating plants and you're eating meat. So bears are considered omnivores, and some birds eat both plants and meat. Now detritivores are scavengers are organisms that eat dead remains of other organisms. So think of like in the Serengeti, in a desert. If you had a dead animal, say this dead camel right here, you're going to have all sorts of things that are going to feed on it. You're going to have coyotes that feed on the dead camel. You're going to have vultures and these different birds. I'm not exactly sure what type of birds those are. Worms you're going to find in dead remains. So these organisms are considered scavengers or detritivores. Decomposers are commonly confused with scavengers. Decomposers are going to take whatever's left of this dead animal, say the bones that things can't eat, and say at the end of fall, what do you have all over the floor of the forest? You have leaves all over the floor. All of these contain carbon inside of them, and they need to be able to be broken down, and decomposers are what are going to break these things down. The most common decomposers are bacteria and fungus. So the mushrooms that you see usually on the top of logs, they are breaking down that log and they're returning all those nutrients to the soil. Now, it's important to learn about those different types of consumers because this is going to define what's called our trophic levels. What this is just a fancy word for saying each step on a food chain or food web. It's saying who eats who. Okay, so the first level are always producers. Remember, producers are producing or making their own food. So these are the plants that are going to be making their own food by using the energy from the sun. So they're making their own food. They're not eating anything. They're using the sun. Then, who eats plants are considered primary consumers. Primary are the first to eat. So if they only eat plants, they're the herbivores, or if they eat plants and meat, they're considered omnivores. So this is the second level. Now, who's going to eat the things that eat plants are the secondary consumers. So one, secondary, second, number two, and those are going to be eating these animals. And then we go another level up and we have tertiary. Tertiary means three. These are the third organisms to eat. So they can be the carnivores, they can be scavengers or decomposers. It depends on the food chain or food web. Okay, so we're going to look at an example of those trophic levels in a second, but what's important to realize about those trophic levels is that the energy is flowing in a food chain or food web. The ultimate source of energy, we said, was the sun. The sun gives energy to the producers, or the autotrophs, the things that are making their own food, using the energy from the sun. And then whatever is eating the autotrophs are considered the heterotrophs. These are organisms that can't make their own food. They have to get food from another source. So a food chain is showing how energy is passed through an ecosystem. When we just looked at those trophic levels, you saw who is eating who. When you're eating, you're getting energy. That's why we eat, right? So we're showing a transfer of energy with these arrows by showing where the energy is going. We're showing energy flow. So the direction of the arrow shows the direction of the energy. This is what trips up most people, because most people think that it's pointing to what is being eaten, but it's the opposite. So let's look at an example here. Okay, so here we have our primary producer. Let's use this example, a plant. It's a producer because it's making its own food. It's getting energy from the sun. The primary consumer is the first to eat. So this would be an herbivore. This is an organism that will eat the plant. So the arrow is going this way because the grasshopper is getting the energy from the plant. Now this little mouse right here is going to be eating the grasshopper, so it's considered a secondary consumer. It's the second to eat. So the energy is going to the mouse from the grasshopper, and you can go up and up. So it depends on the food chain. It might look a little bit different, especially this is a terrestrial food chain, meaning on the land, and here is a marine food chain, which means it's in the ocean. So you might not recognize phytoplankton. We haven't really talked about that, but that is considered a producer. It uses energy from the sun and sometimes chemicals in the ocean. Now, food web is a little bit more confusing. It's not just one link going up. It is all of the food chains in an ecosystem linked together. So think of a spider web is a lot more complicated than just a piece of string. A web is going to go this way and this way and that way and that way. And that's exactly what a food web is. Here we have a food web. Look at all these arrows going all over the place. It's showing, for example, the snake is eating the mouse. Remember, the arrow points to where the energy is going. So the snake is getting energy from eating the mouse. Okay, but the mouse is not just going to be eaten by the snake. The mouse might also be eaten by this red-tailed hawk. Okay? Or the snake is not only going to eat the mouse, the snake might also eat a salamander, or it also eats this bird right here. So this is showing all of the food chains together. Why this is important is because we need to know how we get energy. The first trophic level, which are the producers, are getting the most energy. Why? Why do plants get more energy than us from eating plants? Because plants get energy straight from the source, the sun. Remember, the sun is the ultimate source of energy. So if you're getting energy from the sun, that means you're getting the most energy. And as we go down each step of the food chain, 90% of the energy is lost into the atmosphere as heat. So, for example, in that first food chain, the grasshopper is only getting 10% of the energy from the flower. So that the final people who are eating, the final consumers, are going to get the least amount of energy. And they usually represent that with a pyramid. A pyramid is showing how at the bottom of the food chain, the producers, the ones getting the energy from the sun, have the most energy. They have 100% of the energy because they're getting it from the sun. Now, as those producers are being eaten, 90% is lost. So that primary consumers, like the grasshopper, only get 10% of the energy. Then another 90% is lost. So only 1% of the energy goes to the secondary consumers, and only 0.1% of the energy goes to the final consumers. So you can see that as you go up a food chain, you decrease in the amount of energy. Now, when we're talking about cycles, it's very different. Energy is transferred, right? We show it going from one organism to another. But the cycles, like the water cycle, the carbon cycle, the oxygen and nitrogen cycle, they're not transferred, but they're cycled. That means it's never lost. Remember, 90% of the energy is lost. And once it's lost, you can't get it back. So let's first talk about the water cycle. Okay, this is probably one of the easier ones because you guys know all about water, right? These words sound really complicated, but when we look at the picture, it's going to make a lot more sense. Okay, so the terms for the water cycle are evaporation and transpiration, which is just a fancy word for evaporation from plants. Then we have the term condensation, precipitation, runoff, seepage, and uptake. Let's take a look at what those mean in the picture form. Let's start at the top of the water cycle. So here, let's say we have an ocean or lake or whatever form of water it is. Okay? Think even about a glass of water that you might have sitting by the pool. Right? What happens to that water over time? The water level is going to decrease. The water just doesn't disappear. It is what's called evaporates. It evaporates or goes into the air. It's changed from liquid in your cup into gas. It's going to go up into the atmosphere and form the clouds. So that process of being taken in and turned into gas is called evaporation. Now we all know that trees also have water inside of them. So when there is a tree and the sun beats down on it, it is also going to lose water. And when the water leaves from plants, it just has a fancy term called transpiration. The way I remember that is T for trees. So evaporation is just from any body of water. Transpiration is when it's from trees. Now it goes up into the air and it's going to form a cloud. It's going to condense, condensation. Condensation is when all the little tiny water droplets come together and eventually form a cloud. Now eventually that cloud gets heavy enough that the water has to fall. When it falls is either rain, snow, sleet, hail. It's called precipitation. It's precipitating or falling down from the sky, and it's going to go everywhere, right? It's going to run down the sides of mountains and hills. It's going to go into the lakes and all of those things. So runoff is when it's running down, running off the mountains and hills and all of the features, buildings. Now, it will be in the soil, and it needs to sink or seep down into the soil. That's called seepage. And it's either going to be taken up by the roots of plants, or it's going to be filtered back into the ocean, lakes, and other things. Now, the nitrogen cycle is a little bit more confusing, but the main thing that I want you to know about nitrogen is bacteria. Bacteria, 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 bacteria. What word did I just say? Bacteria. Whenever you see the nitrogen cycle or nitrogen at all, you pick bacteria. That is because bacteria are the key components that are changing the forms of nitrogen in the earth. Okay, now nitrogen is very important because it's needed to make proteins. Okay, so here we have amino acids which make up proteins, and you can see without that nitrogen, we would not be able to have proteins. We would not be able to have our muscles or our hair or our skin or our nails. So we really need nitrogen, and that's why it's so important. Now, we can't just use the nitrogen gas that's in the air, right? It's all around us right now. We're breathing it in, but we can't use it in our body. So what has to happen is bacteria, that key word again, bacteria, 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 is going to change that gas in the atmosphere into a form that our plants can use. Okay, remember, it's very important for us. Now, once those plants have the nitrogen, we get that nitrogen by eating the plants. Okay, so that's how we're going to get it. And then again, bacteria are going to recycle the nitrogen and put it back into the atmosphere where it already started. Again, it's a cycle. And that is the end.